Bless you. 2.5. Transformations of functions. For the 8th period people or anybody else watching this video, I showed a figure from page 255 that would be helpful. That looks, or is the graphs of a bunch of parent functions. All right. So, we discussed most of this last semester, but it would be good to rehash this. So let's talk about translation. So, I'd like you to consider the following. Let's take the graph of f of x equals x squared, and let's briefly draw a sketch of it. I don't really want a super accurate sketch, but let's just get a sketch of it. What does that look like again? X squared. A parabola. Whee! By the way, this is a section where multiple different colors might come in handy if you have that capability. If not, you're just going to have to label stuff. All right. So what does that do? Not the left. Yeah, that actually moves it up too. So maybe roughly here. So that's G. So it probably doesn't take a genius to figure out what that one does. Yeah, that one would move it down 3. So that would be H. So basically, if you have some quantity added or subtracted on the outside of the parent function, that's going to cause a vertical shift. So let's formalize this. Vertical shift. And by the way, for everything I'm about to show you, we're going to let C be a real number, but C has to be positive. Because if C is negative, everything I'm about to write will be backwards. So if I have y equals f of x plus c, what does that do again? So if I take some function and I add c to it, thank you, what does that do? Which way? Up or down? Up. Right. So, usually helps if you start looking at the right notebook. I started looking at my calculus notebook, and I was like, where am I? So, this shifts F C units in the upward direction. And of course, if you have f of x minus c, that would be the vertical shift down c units. Okay, you good? So, here's the next thing I want you to consider. What's the graph of that guy look like? A V. V. So that's F. Now, G is going to be the absolute value of x plus 2. Note the difference in this and what we did on the last one. You better remember what this does. Right, this one goes left. Basically, a good thing to remember is anything that happens on the outside, per se, is vertical. And anything that happens on the inside is horizontal. And the horizontal stuff tends to always work backwards of what you think it should, because you would think that plus would move it right, but plus actually moves it left. So this would be somewhere here. That would be G. Try not to die. So then this one will go to the right 3 units, so it'd be somewhere here. Part of the reason why that works, think about it this way. If I plug 0 into F, the absolute value of 0 is 0. That's where the vertex of this function is. If I were to plug 0 into G, I would get positive 2. I would have to plug negative 2 into G to get 0. That's why the vertex shifts over to negative 2. Similarly, I would have to plug 3 into H to get 0 as an output. That's why that moves over to 3. All right, let's formalize that. So, this is your horizontal shift. All right. Once again, C is a real number. C is positive. So if you have y equals f of x plus c, that shifts f c to the left, and y equals f of x minus c shifts f c units to the right. All right. All right. So, if I had h of x equals, bless you, x plus 1 squared minus 3, and I'd like to identify the transformations to that graph, the first thing I would have to do is figure out what the parent function is. So what's the parent function here? X squared. So the parent, the mother function, if you will, is x squared. So now what's been done to it? Right, so this would be 1 to the left and down 3, right? And I'm okay if you write it like that. You know, that tells me exactly what I need to know. If you want to write it out in words, feel free. And of course, we could graph that. All you'd have to do is draw a parabola, and the vertex would have to move to -1, -3 from the origin. All right. Let's take a look at reflection. I think I ought to be able to squeeze part of that into this video.
4 minutes.
Thanks. They probably heard you really well because you're sitting right there. All right, the easiest way I've found over the years to teach reflection is to take a coordinate in the first quadrant, or a point in the first quadrant, and then reflect it and see where it ends up. So if I want to reflect this point about the x-axis or in the x-axis, where would it end up? X negative y, I agree. So that would be in the fourth quadrant. All right. So the thing to remember here is that y is equal to f of x, right? And so if I want to take something and reflect it in the x-axis, I take the entire function and make it negative. So that negative is on the outside, because if you think about it, and people watching the video can't see this part, but an x-axis reflection is almost like a vertical reflection. You're kind of doing this. And remember that all the vertical stuff happens on the outside, right? Okay. So if I want to reflect that point in the y-axis, where would it end up? So if I take this point, reflect it across y. All right, so it'd end up over here in the second quadrant at negative xy. Now see, in this one, the y stays the same, but the x changed sign. So if I want to reflect in the y-axis, I'm going to get y equals f of negative x. So the negative goes on the inside for a y-axis reflection, whereas for an x-axis reflection, it's on the outside. If you think about it in terms of horizontal and vertical, a y-axis reflection is like a horizontal reflection. It's doing this. Got the tie flying around and everything. All right, so that's how that works. So let's say I want to take f of x equals the square root of x. And we're just going to draw a quick picture here. We're not going to make this super accurate. What does that graph look like again? Yeah, I showed it to you at the beginning of class. It's like half of the sideways parabola like this. So that's f. Well, somebody went to SAC, and I'm pretty much out of time, so we'll figure out what G is on the flip side.